When we did the analysis of variance and the analysis of means, we were assuming that the data were normally distributed. If they are not normally distributed, there's another test we can use. It's called the kruskal-wallis test. And unlike the analysis of variance and analysis of means test, it's not going to actually use the growth data per se. Instead, it's going to analyze the ranks of the growth data. So if we assume that the treatments have no effect, then the rank orderings of the growth from these different treatments should be randomly distributed, and they would all have approximately the same average rank. So that's the basis of the kruskal-wallis test. Now let me use Excel to show you something. I'm going to use the Excel function called rank, and I want Excel to tell me about the rank of this particular value. I'm going to double click on this function just to show you what it looks like. I want it to tell me something about the rank of this particular value versus the rank of all these values. And what I'm going to do now is I'm going to press the F4 key, and you'll see that that makes all of these references absolute. It puts dollar signs in front of them, meaning when I copy this cell, these references won't change. So I'll now go back to the function, and I want these to be sorted in ascending order. So I want the smallest one to have a rank of 1, the next smallest one to have a rank of 2, and so on. So I can put any non-zero value into this cell. I'll put a 1 in, and it's going to now tell me that the 15.1 growth rate is the 13th largest growth rate in this data set. So looking at these data, to my eye, it appears to me that the rankings for treatment number 2 are on the smaller side. The rankings for treatment number 3 are on the larger side. And the rankings for treatment number 1 seem to be randomly scattered throughout. So that's my gut. Let's see if the kruskal-wallis test confirms that. So I go back to minitab. I'm going up to the stat menu. And the kruskal-wallis test is called a non-parametric test. So I'm going to go down to that choice, down to the kruskal-wallis choice, and click. And I've already selected growth as the response I want to analyze and treatment as the factor I want to analyze. And there are no options in kruskal-wallis, so I'll click OK. Then, as before, I'll click the session window, and here's the result. So what I see is that for treatment number 2, I get a z-statistic, and just like the normal distribution z-statistic, a large negative z is unexpectedly small, and this is a minus 2.38, so that's on the larger side for a z value. And for treatment number 3, the z-statistic is also well above 2, and it's on the positive side. So the differences in the ranks are significantly different between the treatments 2 and 3. The p-value for these differences is 0.013. That's smaller than 5, so we conclude that there are differences between these two treatments, just like we did with ANOVA. Now, ANOVA's p-value was 0.003, and this one's quite a bit larger. That's because non-parametric tests are less powerful, but nonetheless, we were able to do this analysis without the assumption of normality.